This is class is all about Bayes theorem. So Bayes is one of the mathematician. Based on his principles, how does it is possible? His principles, his theorem helps us in the machine learning is. Before understanding this topic of Bayes theorem, we should know what is conditional probability is. Probability was another topic from the your SSC or 10th class onwards. It has come. Even in your first semester course also, the P&S was there, probability and statistics. So this was the subject is already there. Let me brush up your knowledge in this topic, and that allows us to understand these entire topics in a very fast manner. The way you are getting these points are towards an understanding of machine learning. Not for this is called doing the problems in the probabilities. Especially the problems all helps us to understand the Bayes theorem, and automatically it allows us to understand the machine learning is. So what is actually probability is a bedrock of machine learning. So we cannot develop a deep understanding and application of machine learning without it. It is not possible to develop any machine learning algorithm without the deep understanding of probabilities. So probability means probable. What are the chances? Probable means what are the chances? From that probability came into existence. So the cut through the equations, Greek letters and confusion and discover the topics in probability that you need to know is you need to know the equations, some letters, Greek letters, and some of the topics in the probability we should know. Using clear explanations, standard Python libraries, and step-by-step tutorial lessons, it is possible for you to understand the probability, importance of probability in machine learning, the Bayesian probabilities, entropy, density estimation, maximum likelihood, and much more. All these topics would come to you. That is called here now the probability of Bayesian, entropy, density estimation, maximum likelihood, and much more. So then, machine learning doesn't make sense without probability. That's very clear for us. So there's nothing, there is a meaning of machine learning without the probabilities. So always you have seen from the linear regression, logistic regression, always you have already had a scene about this, the importance of probability indirectly. Because if this is going to be happen, what to do, what not to do, all these things are what they call the probable chances are. What are the decisions to be taken is very important for us. So uncertainty involves making decisions with incomplete information, and this is the way we generally operate in the world. So uncertainty is there everywhere. Okay. So when the uncertainty situation happen, what type of decisions you make is very important for us. That uncertainty involves making decisions with incomplete information. When uncertainty happens, so we need to take decisions, and information is available with us. No, there is no complete information with us, but you're supposed to take a decision compulsory. And this is the way we generally operate in the world. So whenever you are in the field, you're supposed to work, right? There is no chance where you come back again to take some action and go back. So once you are on the field, you are supposed to take a decision immediately. Information available with you, all are with you, but you should come into picture immediately. So handling uncertainty is typically described using everyday words like what are the words comes whenever you want to handle uncertainties, that the words we say called chance, luck, and risk. These are the words generally we use to talk whenever uncertainty comes into our life. Probability is a field of mathematics that gives us the language and tools to quantify the uncertainty of events and reason in a principled manner. Before that uncertainty happens, so it's better for us to know what type of situations are going to come, what decisions to be taken. That possible for us to put on a paper to a subject, that is probabilities. The field of mathematics gives us the language and tools to quantify the uncertainty of events. I would like to quantify. I would like to know how many uncertainty of events are happening and what is the reason behind of it. All these things I would like to know is possible through the probabilities. We can assign and quantify the likelihood of things we care about such as outcomes, events, and numerical values. It is possible for us to know the outcome of each and every uncertainty event through an outcome, through events, as well as numerical values. It would be fair to say that probability is required to effectively work through a machine learning predictive modeling project is. Machine learning is about developing predictive models from the uncertain data. Uncertainty means working with imperfect or incomplete information. From the beginning, I'm saying that. So machine learning is about developing predictive models from uncertain data. So prediction is possible for us to do it using the machine learning. And whenever I have for uncertain data that time machine learning should help us. They help us to develop models so that it is possible for us to know to take decisions in uncertain situations. So uncertainty is a fundamental to the field of machine learning, that it is one of the aspects that cause the most difficult for beginners, especially those coming from a developer background. Sometimes we are now gone. So this type of probability is somewhat difficult, looks like that, but we should have an approach that it is possible for us to know that it's called. What are the three main sources of uncertainty in machine learning? Okay, slowly I'm going to machine learning concept here. So there are three main sources of uncertainty in machine learning. What are that? The data is noisy. Data is very noisy, very clumsy. Okay, unable to understand. Incomplete coverage of the problem domain. Incomplete. Okay, so what are the data you got? It's not completely covering about the problem domain. So noisy data, incomplete coverage of the problem domain, and imperfect models. The model you have developed is not suitable for the data. Okay, so three problems would rise. So there are three main sources of uncertainty in machine learning: noisy data, incomplete coverage of the problem domain, and imperfect models. Nevertheless, we can manage uncertainty using the tools of probability. It is possible for us to maintain it to the probabilities. As machine learning practitioners, you must have an understanding of probability in order to manage the uncertainty we see in each project. It is possible for us to see each every project how to maintain it. So in fact, probability is the bedrock of machine learning. Classification models must predict the probability of class membership. Algorithms that are designed using probability. Learning algorithms will make decisions using probability. Subfields of study are built on probability. Algorithms are trained under probability. Models are fit using probabilistic loss functions. Model hyperparameters are configured with probability. Probabilistic measures are used to evaluate model skill. All these things and list so goes on like that. How do you say that probability is the bedrock of machine learning? There are some examples have been given. So just now I said a glance about this one. At the end again we'll have a look at that is it correct or not. You should come to the conclusion about that whatever he is saying that is correct or not based on this classes. Let's start the properties. So in this class we'll have basics about the probabilities. I'll teach you all the basic concepts, what are the terms comes in the probabilities. I already said that might be have learned all these topics in your previous courses, first semester as well as the intermediate and the SSC. So let's see one more time about this one, because let's have a brush yourself about all these topics so that it is possible to understand and you can close it. So one of the most important things, the examples comes is called tossing a coin, right? This best example, everyone starts with the probability with this topic only, tossing a coins. So a coin consists of two, so head and tail. Two sides it has, head and tail. So if you toss a coin, what is the here now getting a chance of getting a head? What is the chance of getting a tail? That is called what is the chance of getting what is the probability of getting a head and as well as the called tail. So what you have is called here now. So what the formula you used to have is called, so what is the chance of getting is one is possible out of two. So we used to write 1 by 2. So head chances is called 1 by 2, tail chances are 1 by 2. If we add these two, 1 by 2 plus 1 by 2, again becomes a 1 only. So what are the probable chances are there if you have written all these things, and if we add all the probable chances, the summation should get 1. Is very most important. Summation not getting 1 means the probable, what are the here the probable of chances of everything is wrong. So the summation of each and every probable event, the sum should equal to 1. So this is called an event is. In this context, what is the meaning of event is? An event is simply the outcome of a random experiment, right? So getting a heads when you toss a coin is an event. Getting a head, okay, getting a tail when you toss a coin is an event. You are not on head, tail also. So getting that is called event. Okay. So something here like random experiment, you're doing some experiment, that one is called. So getting a 6 when you roll a fair dice is an event. So then suppose I would like to get, I want to get a 6. So what is chances is called 1 by 6 only chances are there. So we associate probabilities to do these events by defining an event and of course and the sample space. This is the sample space where one particular place available, there we are defining all these things is for. In this context only we are defining that. It is called sample space. And when we come here now, union of events. The two events are going to be happen. I would like to union it. That one is called. This is a very famous symbol, as you know, that is called. So you have seen that is for two circles have been drawn like this, right? And this is, as you know, that this is intersection, and this is a what you have, two of them is there. So this is, you can say A and this is B, and this part, whatever this part you have, is called A minus B. So minus B is subtracted, and this comes in. So this is a 1. So only whatever B is there is subtracted. So A minus B is here. Now this is B minus A. This place is B minus A. Okay. So like this comes here now. This is intersection. So we can define an event C, for example, of getting a 4 or 6 when rolled fair dice. Here, event C is union of two events. So event A, what is event A is getting a 4. So event is just I said now, event A is equal to getting a 4. Event B is getting a 6. Okay. So what is here now called probability of C? This is the way to write. Probability of C is equal to probability of A union B. Like that, we have intersection. Here I can see intersection here. Let's see the event of getting a multiple of 2 and 3 when you throw it fair dice. So let's see. See, I'm thinking that C is a event of getting a multiple of 2 and 3. 2, 3 are 6 now. So when you throw a fair dice. So event A is getting a multiple of 2 when you throw a fair dice. So we are thinking that event A is multiple of 2. What is multiple of 2? 2, 4, 6. Okay. So even B is getting a multiple of 3 when you throw a fair dice. So 3, 6. So even C is getting a multiple of 2 and 3, combination of 2 and 3, that is called 6. So here also 6 chances there, here also 6 chances there. So I would like to see called what is the here now called combination of both the things. Multiple of 2 and 3. So intersection of these two things is for 6 is there. So even C is intersection of even A and B. So probabilities are then defined as probability of C is equal to probability of A intersection B. Probability of A intersection B. How do you define this in Venn diagram? Huh? So this is called Venn diagram of this one is. So this is A, this is B, and this is the here now. So we are writing here now called 2, 4, and here writing called 6, and here writing called 3, and the left 6. So 6 is the chance of getting here now. Okay. There are disjoint sets also here now. Separate sets we have this is called. Suppose example sample space 1, 2, 3, 4, 5, 6 is the space. So what if you come across a case when any two particular events cannot occur at the same time? Two events cannot occur at the same time. So what do you have chance of it? So we have fair dice and we have only one throw, only one chance for it to get that one is caught. So even A is getting a multiple of 3, even B is getting a multiple of 5. So you want both even A and B should occur together. You're thinking that both A and B should together. But chances what you have is here now, very less. No chances of it. Why? Because the multiple of 3 means called 3, 6. And multiple of 5 is only 1, that is called 5. So what is chance of getting a combination? There is an intersection possible for this. In previous case, we have intersection is possible called 6 is a probability there. But here in this case, there is no chance of getting. That's why here the sample space can stuff like this. So you can see that there is no case for which event A and B can occur together. Such events are called disjoint events. Represent using Venn diagram. This is the diagram that represents this. So here now called what do you have for 3, 6 here, and here comes 5. And this comes. So independent, dependent, exclusive events. So here now I need to go to the conditional probabilities required for you. So that is a topic for us. So before that, these are the basics for us to understand the topic is. Let's see how many of you. Let's see that. Are getting my point? Let's say respond to this question because we're going to next phase. Okay, basics are finished. So why do you need probability here? We are studying probability in this machine learning concept. So what are the basic definitions of probabilities? What is this? What is this one is called probability? What is meaning of here now called probability of getting a chances here now? The dice as well as you have seen called coin, all of this. Okay, good. At least responded. Let's start the topic is. So suppose we have two events, event A and event B. If the occurrence of event A doesn't affect the occurrence of event B, these events are called independent events. Okay. So there are two events. We have event A and event B. Okay. So event already have seen occurrence here now. So if event A doesn't affect the occurrence of event B. Okay. Separate, both of them separate. There is no effect is there. So both of them doing their own, right? So that is independent events are. The occurrence of event A doesn't affect the occurrence of event B. These are called independent events. Let's see some examples of independent events. So getting heads after tossing a coin and getting a 5 on a throw of red dice is independent. So when you toss a coin is head or tail, when you throw a fair dice is called getting a 5 is separate one. So there is no link. You cannot link these two things. So these two of them can be referred as independent events. Choosing a marble from a jar and getting a heads after tossing a coin is also independent. Choosing a 3 card from a deck of cards, replacing it and then choosing an ace as a second card is also independent here now. Okay, the cards here now we have two cards are there. Already you have discussed all these things. How many cards are there? What type of cards we have? Already discussed. Now here my aim is not to discuss about what type of cards are exist. What is the heart? What is the diamond? All these things. Okay. Rolling a 4 on fair dice and then rolling a 1 on second roll of the dice is also independent. Okay. In each of these cases, the probability of outcome of second event is not affected at all by the outcome of the first event. And how do you represent this one? Probability of independent events are. How do you represent? Representation is important for us. Not discussion is important here now. Discussion is over already. Everything we should represent on the paper so that it helps us to do the preparation of the machine learning model. Then automatically, when you have prepared a model, then what is the advantage for us? So that it is possible for us to face the uncertainties. That is the purpose of all these things. So let's see, this is called in this case probability of A intersection B. So probability of A into probability of B is okay. So how do you represent this for intersection here now? How do you do the calculations? All these things is possible to the probability of A into probability of B. Let's take example here. So you win the game if you pick the red marble from a jar containing 4 red and 3 black marbles, and we get heads on toss of a coin. What is the probability of winning this? So let's define an event A getting a red marble from the jar. How many are there? 4 plus 3, 7 are there. Okay, getting a 4 red and 3 marbles is. So what you now call we win the game if you pick a red marble from a jar containing 4 red and 3 black marbles. Already there are 7 marbles are there, and 4 of them are red and 3 of them are black. And here now I need to pick one of the marble. If it comes a red marble, that means you are the winner. Okay, and here now called. And if you get a heads on toss of a coin, at the same time, once you got is called red, and also I'll do the toss of a coin. And if you got the red head, that means you are the winner. So two events are there here now. One is called picking a red marble from a jar of 4 red and 3 black, and also you need to get a head when I toss a coin. That's getting a event A is called probability of A is equal to 4 by 7. Okay, so there 4 are there, 4 marbles that you have. So chance are 4 out of 7, and probability of B is 1 by 2. Okay, now I need to solve both should happen. So probability of A is equal to 4 by 7, and probability of B is equal to 1 by 2. And what are the chances we have getting is called 2 by 7. Okay, so that 2 by 7 is called 0.2 something is coming 20. So almost called 0.3. Okay, 0.3 chances are there. So 0.3 chances are there of getting this doing this type of things. What is that is called? So getting a red marble out of 7, out of them is called 4 red, 3 black marbles, and getting a heads when it toss the finals. This is the way we represent it. I'll share the PPT. It's possible for you to note it down. So probability of dependent events also sometimes exist also. Probability of dependent events also. In this previous probability of independent events. Next, can you think of examples of dependent events? In the above example, let's define event A as getting a red marble from the jar. We then keep the marble out and then take another marble from the jar. No. So what are the marble we got it? We just keep it outside and we try one more time for that one is called. What is the probability that second case will be the same as that the first case is? So I should get the second also red only as compared to as similar to the first case. Let's see. So for the first time there are 4 by 7 chances as you've seen that getting a red marble. Let's assume that you got a red marble on second attempt. Now number of things should be taken into consideration 6 because one is not there. Na? So 6 should be taken into consideration. Now for second chance to get a red marble, one is already not there. So 3 by 6 chances. So 3 by 6 means for 1 by 2. Right or not? So if you didn't get a red marble on first attempt, but a white marble instead, then there were 4 by 6 chances to get the red marble second time. So what is that is called? If you didn't get a red marble first attempt, but a white marble instead, white marble is black marble actually. Here now it should be black term because black marbles were there. So black marble instead, then there are 4 by 6 chances to get the red marble second time. Therefore, the probability in the second chance case was dependent on what happened the first time. So what is that? It's called chances are there. Like that, what happened is called the previous case also. This is called probability of so dependent events are. So what is mutual exclusive and exhaustive cases are? Mutual exclusive only word is there in operating systems. Okay, the word mutual exclusions, all these words are there. Mutual exclusive events are those events where two events cannot happen together. Okay, so not inclusive. Inclusive means happen same time. That's opposite of inclusive. Exclusive. Exclusive events are those events where two events cannot happen together. Is called. The easiest example to understand is toss of a coin. Getting a head and a tail are mutually exclusive because you cannot get either both the things. Either you get heads or tails, but never both at the same time in a single coin toss is called. Okay. There is no chance of getting this one is unless both the sides only one is there. Heads on the one side, other side also head is there. So whenever you toss a coin, you get only always head only, na? Okay. So what you have in the movie of Sholay, Amitabh Bachchan does like that one. Every time this is called Dharmendra says called the tail, and always he loses. At last he comes to know that both the sides only one side, only one is there. That's called head. So like that, there are very rare situations happens in the movie only it happens. Real life it won't happen like that. So this is the reason that now what you have is called. So it won't happen mutual exclusive. Getting a head and a tail is mutual exclusive. A set of events is collectively exhaustive when set should contain all the possible outcomes of the experiment. Okay. Now we'll make a set here now. Okay. So a set of events is collectively exhaustive and set should contain all the possible outcomes of the experiment. So one of the events on the list must occur for sure when the experiment is performed. So I want to know what are the all event chances are there. I am putting on paper. What are all chances are there? For example, in the dice, red dice, so 6 are there. So what is chance of getting 1, 1 by 6, 2, 1 by 6, 3, 1 by 6, 4, 1 by 6, 5, 1 by 6, and 6 also 1 by 6. Okay. Now what you have my space consists of is all the 6 of them I have. I said in the beginning also, if you add all these 6, the answer comes as 1. So answer should be 1 here. There is no chance of thinking of some other one. For example, today dice is the exhaustive collection because it encompasses the entire range of all possible outcomes. Consider outcomes even. Now, what is the chance of getting even is called 1 by 6, 1 by 6, 1 by 6. So 2, 4 or 6. And not 6 is called 1, 2, 3, 4 or 5 in a throw of a fair dice. So they are collectively exhaustive but not mutually exclusive. As I said, here also coin also 1 by 2, 1 by 2. So both are mutually exclusive one. We can write the conditional probability as a probability of occurrence of event A given that B has already happened is now. Okay, conditional probability point of view now. Okay, so what is the probability of occurrence of event A given that B has already happened is, and event B is already happened, and what is chance of getting A? Okay, what is chance of getting A? Example, very simple one here now. So let's say everyone likes, most of you like cricket is. So now called, so Ashwin bowling to the South African batsman, and here now called there is here now called LBW claim. So when the LBW claimed, here now called umpire said no, it's not fair. So it's, there's no chance of. Then the what you have new captain went to the third umpire. So what is here now getting a chance of getting his call out, because we already happened this call. Okay, this call Ashwin bowled already. So bowled to the batsman. Now what you have is 30 chance of getting, even this 30 chance of getting a out. Okay, that's why all the fielders went for the third umpire. So this is what you have is called conditional probability is called. As the probability of occurrence of event A given that B has already happened is called. Bowling is completed, and now you are all the fielders are claiming that he's out. So that's the thing is called. Let's say a simple game of cards for you understand this point is. Suppose you draw two cards from a deck and you win if you get a jack followed by an ace without replacement. What is the probability of winning given we know that we got a jack in the first turns? So what is the chance of getting a jack in the first term? And second time, what is the chance of getting an ace? Okay. So without any replacement is called. Let event A be getting a jack in the first turn. Okay, let event B getting a ace in the second turn. So we need to find it out already. Already you know that is called. How many jacks do you have? 4. How many aces do you have? Is called 4. Okay. So what do you have is the probability of A is 4 by 52. Probability of B is 4 by 51. Why 51? Because of whatever the card you have taken is called, you have removed it. You didn't replace it into the deck of cards. So now number of cards have come down to 51. And what is here now getting here now probability of A and B both here now getting is called 4 by 52 into 4 by 51. A and B in the intersection. So probability of A into probability of B. So answer is called 0.006. So here we will determine the probabilities when you know some conditions instead of calculating the random probabilities. So here we know that we got a jack in the first turn. So this is the conditional probabilities now. Okay. So probability of chance of getting A after the already B is happened is. Conditional probability arises naturally in the investigation of experiments where an outcome of a trial may affect the outcome of the subsequent trials. One trial is already happened and automatically it affects the outcome of the other events also. That is called conditional probability is. So we try to calculate the probability of the second event given that the first event has already happened. If the probability of the event changes when you take the first event into consideration, you can safely say that the probability of event B is dependent on the occurrence of event A is. Okay. So we try to calculate the probability of second event given that first event already happened is. Okay, we try to find out probability of second event given that first event has already happened is. Then what happened is called B is dependent on A. There's no doubt about that. It's called B is dependent on A is called. Okay, this dependency already have seen now in the DBMS point of view. Functional dependency, such type of concept already we came to across about this dependency point of view. So one event happened, the automatically here now the other event is there, other event dependent on this one automatically comes. Because suppose you want to go outside, okay, that's a example event B. And event A here now you are supposed to start your bike. For example, you need to start bike event to happen event B. If you want to go and do some shopping, so next first of all you need to go to the shop first of all. Then only it's called shopping is. Otherwise it's called what they call e-commerce shopping because you're staying at home and using mobile and doing some shopping. So if you want to go to the shop, so you need to travel from your home to the shop. Then only that event happens is. Let's think of case where this happens is. Drawing a second ace from a deck given we got the first ace. Finding the probability of having disease given you tested positive. Finding the probability of liking a Harry Potter given you know a person likes fiction and so on. You can define two events. Event A is the probability of the event that you are trying to calculate. Event B is the condition that you know of the event that has already happened. Let's see example of how much relevant to our present situation is. Because second one you can see that. Then find the probability of having disease when you were tested positive here now. What is that? You already know that is called. Okay, that is the most important thing. What is the probability of getting here now? First, you need to give some sample to them. Then, if the positive comes, then second thing happens is. Suppose if you not give here now testing purpose, then how do you know that is called this is happened or not? That's required here now. Then also, what you have is called Harry Potter. Somebody likes Harry Potter means the person should like the fiction. Then only the person likes Harry Potter. Suppose I don't like the fiction, why should I? Then automatically I don't like the Harry Potter. I hope so that most of you know Harry Potter stories. Otherwise, you won't understand what is this Harry Potter is, right? And so on here now like this way. So why this is relevant to machine learning? How do you can you say how is relevant to machine learning? Machine learning, if you want relevant to it. Sorry, a person is whenever he is coming to shop, so he's always purchasing along with milk. So along with milk, he's also purchasing butter or he's purchasing a bread. So now, whenever he's coming purchasing milk, he's also purchasing a bread. So that means come here now, conditional here now. So whenever he want here now called bread, he wants to purchase, milk should be there in a shop. So if there is no milk, he won't purchase bread also. That is a problem also for us. So that see that is called as a business person, as a storekeeper, you should see that both should be there in your shop, right? Who the customers are coming into your shop, especially in the morning time. So morning 7 o'clock to 9 o'clock. So almost they're purchasing milk and they are also purchasing along with the milk, they are also purchasing the bread. So you should see all the stocks of the both should be there in your shop because 7 to 9 most of them coming and purchasing it. And in this war purchasing the milk, and how many of them purchasing bread? The purchasing bread, for example, is only 60% of purchasing the bread also. Because second day they won't purchase, already stock is there in the home. Why should they purchase one more time? Meaningless. So that's why we are taking the sample size of example is for 60%. So that's the thing is now here now. So that means now here both should be maintained. This one is called then only that possible for us called condition probability happens for us. Let's take another example. Suppose you have jar containing 6 marbles, 3 black and 3 white. This one was 3 black and 3 white. What is the probability of getting a black given the first one was black 2? Okay. Getting the black here now because first one is already black here. Now probability of getting a black in second time also. So probability of A is called what you have called when we have 3 by 6. Okay. Getting a black marble in the first one is 3 by 6. Second time what you have is to remove the first one, remove the one of the thing. And remaining 2 of them we have. So 2 by 5. So already I have seen that 1 by 6 is equal 1 by 2 into 2 by 5. That is 1 by 5. So 1 by 5 means 0.2 chances are there. Okay. So 0.2. And same time you need to convert sometimes to the percentage also. So 1 by 5 into 100 is equal 20% chances are there. Getting the second time also a black marble is. Probably A and B both should happen. Chances are equal 0.2 percentage there, but 20% chances are there getting like that. So what do you have? How do you relevantly again this one to the our machine learning? Suppose now what is the temperature do you have is what is chance of getting a rain now? So what do you have is called probability of A is what is that, probability of B is what, probability C is like this. All parameters should be considered. What are parameters? The parameters what you have is called like this here now is suppose what is humidity is there, what is this month is there. What about this called the temperature right now do you have, right? And what we have the right now called clouds are there or not outside. So these are all parameters should be considered. Clouds, humidity, as well as temperature, and the month also sometimes also need to be considered. So all these things probability take into consideration, and later on we'll do the intersection of all these things. We'll do the intersection of all these things. Then we'll consider what is the chance of how much chances are there getting a rain is.